Hi everybody. Since there's now a handful of you who are interested in doing some science over the summer, I thought I'd record a short video and talk you through some of the details so you can do a little bit of self-directed work and digging around and a little bit of learning over the summer weeks and months. So I've set up a web page and a GitHub repository, which I will tell you about in a little bit. And the general theme of this of these exercises that you can do and sort of ideas for little projects to work on has got to do with images. And so images in the sense of the kinds of images that we use to display as visual stimuli in cognitive neuroscience experiments, but also images in the sense of the data that we acquire often with biomedical imaging devices such as MRI scanners, which is the tool that I use in my research. So since this is probably not stuff that you were taught at high school or even in your first year of undergrad, there's some exercises here to get you started. The general tools for exploring these things is a programming language called Julia, which is free and open source, and I'll talk to you about that in a couple of minutes. I'll give you some more details. But as you're going through this stuff, if it turns out you're more comfortable with another programming language such as Python, which you may have learned at high school, then feel free to explore ways of coding up the solutions in that different language, right? So the web page is at this address, okay, and so this is just a nice rendering of a little README file that I've created, and so you can read through that. It's got sort of an outline of a general plan. It's got a little bit of instructions on how to get started with a Jupyter Notebook, and also some specific problem sets that we can be working towards. Okay, so there's a couple of links here, which I will show you in a second. I've recorded the first steps with the Jupyter Notebook, which you can go through. And then there's also a link here to an MIT OpenCourseWare course called Computational Thinking, which is quite mathsy towards the end. But actually the beginning bits are really super useful and might be very useful for you. One especially useful aspect of that course material is it's actually got the person who came up with this Pluto notebook, which I'll show you in a minute, giving a demonstration of how to install it on a Windows machine rather than a Mac, so that might be useful for you too. Okay. So just to orient you a little bit more, so this is ideal for reading the text that I've rendered here. But the code and some of the data files that you want to be using are actually on the GitHub repository. So at this point, if you don't know what a GitHub repository is, maybe you can spend half an hour finding out on a YouTube tutorial on some web pages what a little bit about version control and what GitHub is all about. But this is my way of sharing the data files with you and the code as well. And you can see actually here's this text that we're looking at just included as an actual file. So you can download this code. The simplest thing at the start, if you're not familiar with this stuff, is to probably just download the zip file. But if you are a ninja or if you started learning how to use this version control, there's other ways of getting hold of the code, which will allow you to keep track of if I make any changes in the future. Okay, so that's an important learning point. This version control is a very useful thing to know about if you're interested in doing any sort of scripting or programming and stuff later on. There's also got lots of other useful use cases, which we can talk about at some point. So I'm going to jump right in with a quick demo. So I will download a zip file. So I'm going to download this repository as a zip file. So it's not small, so it's going to take a minute. Right, so on my machine this is already unpacked, so it's in the downloads folder. And so I am going to open a program called Terminal on the Mac, which looks like this. And I'm going to change directories into this folder that I've just created. So the command for doing that is desktop, a special symbol called tilde, which is my home directory, downloads, and if I press the tab key, then I can see that there's a UON folder. And I can go inside this thing here. So Control L clears that window. And if I type ls, you should be able to see that there's now a whole bunch of files in there. Okay, so a neat trick on the Mac is that if you want to look at some of them, so JPEG files and PDF files, you can use a command called open. So you can see that I've included a photo from my Flickr stream. So that's one nice way of doing that here. I've set my computer up so I can type Julia at the command prompt here. You might have to double-click the application and get to that folder in some other way, if you've installed in a slightly different way. And in order to activate this environment here, I am going to press the close square bracket, which gets me into the package manager, and I can type activate dot, and you can see that this version 1.6 tag at the beginning has changed to something slightly different, which means I'm now using packages that are available here, and then you might have to also do instantiate it the first time you're running this. And on your machine, this might take a couple of minutes because it has to download some dependencies and packages. All right, so that's done for me. So I'm going to hit the backspace key. And the next step is to type using Pluto. And so this will allow me to run a little notebook in a web browser, which we'll see in a second. And then I'm going to say Pluto run, not ruin, Pluto run with open and close parentheses. Okay. And if you've set up your machine correctly, downloaded these packages, then what will happen is it will pop up in this web browser view, which is a very nice way of playing around with this programming language. So there's a new version of Pluto available, but I'm not actually going to update this now. It's fine for now. Okay, so you might not get this message. So in this folder that I was looking at before, there was a file called brain-notebook.gl, and that's the one I actually want to open. So if I start typing open a file from brain.notebook, it actually can recognize that in that folder where we started the notebook, there's a file present here, and I'm just going to open that one. And so if this is the first time you do this, it might actually take a couple of minutes on your machine to run, but hopefully it won't be too burdensome. You can see the progress bar up here. I'm going through the loading process for the notebook. And so the idea here is that if you've used Python before, you might have used something called a Jupyter Notebook. This is very much the same thing in this Julia programming language. And so there's lots of tutorials online for exploring this, from very simple concepts to much more complicated stuff. So I'll encourage you to have a look at that if you find some of this stuff confusing. So I've pre-filled some bits of code in here that will help you get off the ground. And in particular, the first few lines here are just including some packages that are useful for doing some tasks, so we don't have to reinvent the wheel every time we want to load in some images and so on. And you can look up details about these packages if you're interested in some of the details. So there's a couple of really nice things in these notebooks. So the first thing I'd like to point out to you, which would be quite important, is there's a sort of a live documentation built in. So if you click on a word and select it, and then press this Live Docs button, it will try and give you some help if it can. So if the programming conventions and command calls and so on have been documented properly, then it will pop up. You can close this window back down again here. You can also get information about complete packages. So I think that should also work. Oh, maybe not for this one. Okay, but for this package here, it looks like it tells you what some of the things are actually doing. So that's sort of a useful way of getting a little bit of help if you get stuck, as well as doing Google searches and so on. So I've pre-filled in here a couple of these cells, which are highlighted in this slightly beigeish color, and it includes some things where we're actually trying to load in a Nifty file in this first example here. So Nifty is a format for storing brain images. And I just wanted to give you a point of how to actually do that. So in this first line here, what we're doing is we're loading a file from the data folder, which I've given you along with this in this zip file that we downloaded, and we read it into a variable called im, which we can then use. Okay, and so here's a couple of things that we're doing with this variable. So I am selecting a slice out of this data set and dividing it by a number. So there's some explanations here. So one of your first sort of things that you'll have to figure out is what some of these typographic symbols actually mean. So I suggest, if you're completely new to this, you have a look at some very introductory lessons on this Julia programming language to get some ideas about what's meant by indexing, what a variable is, how we can assign values to variables, and so on. And there's lots of good stuff online on YouTube and via Google as well. But just to show you something in action here, I've actually coded up this little demo. You can see actually we can go through slices of this brain image. And one really useful thing would be in the first few days when you're getting your head around this stuff is to try and understand how this whole thing is actually set up. Okay? I want to do a little bit of live coding right now just to give you some ideas of what other things to do. So, for example, let's load in a JPEG file that's stored in the data folder, right? So, and just to go back here, if I open a new terminal, so I can open a new tab in this window, in this terminal window, and I do ls to display what's there. If I change into this data directory, you can see that there's a whole bunch of files with different endings, but there's a file called dog, jelly, JPEG, mustache, JPEG. And one thing we might want to do is to manipulate these images by doing some maths with them, for example. So the first thing we'd have to do is actually load them in. So how do we do this in Julia? So what I'm going to try and do is I'm going to load these files in. So if the appropriate packages have been loaded, then that should work. And I need to specify in inverted commas a piece of text that tells this cell where the file is actually located. So in this case, it's in a folder called data. And then I need to give it the file name, which is jelly.jpg. Now, if I want to hold on to this information and reuse it, I need to assign it into a variable and give it a name, basically give it a tag. So maybe I'm going to call that my image. And the way you assign something from the right-hand side into the left-hand side is to use this equal sign, which basically says stick whatever comes out of the command on the right-hand side into a variable that I want you to call my image. Okay? And so you can either press the play button or on the Mac you can press Command Enter to run this cell. It will take a little second, and lo and behold, we've loaded in this jellyfish image. Okay, just to show you that it's actually really working, is if I replace this with mustache, then I should get another image. So I'll scroll down and see. Oops, there's no file called mustache. Oh, I misspelled it, so that's a useful point. So this is an error message you might see quite often. If you mistype something, then the notebook will try and do exactly what you told it to do. In this case, there is no file called MOU. It's got only a U in it. So let me try and run this again, and that actually worked. Okay, so useful learning point right in there. You can actually download images straight from the web as well. So I just want to show you. So directly loading those things from a web page, these resources doesn't work. So you have to first of all download them and hand them over to this function called load. But with a little bit of looking around on Stack Overflow and some Google searching, I basically figured out how to do this. So just as a general piece of advice, this is often a good starting point, right? So I'm going to go to Wikipedia and to the brain page. And if I right click on here, you can actually look at what the image address is, right? So if you copy and paste that, go back to the notebook. So if we add a field here and basically say URL, which is, where is this located? So that will create a variable that contains a piece of text. So I can do download, and I think, so I haven't tried this myself, but let's just give it a go, see what happens. I actually downloaded this to a temporary file. So on the Mac OS and Linux operating systems, they get sort of renamed into these random strings. But we can actually load the file straight from there. So if we wrap this call in the function call for load, right? So you may remember maybe from GCSE or A-level maths, the things that happen inside the parentheses happen first. So there's going to be a download of this URL, and then we're going to load it, which will load the image into the notebook, and that works. Okay. And just to show you, because you might see it in some code as well, there's quite a neat way of stringing these commands together. If you want to hand it over to the next command in a chain of functions, there's a special way of doing that, which is you basically create this special typographic rule for basically saying if you take a vertical bar, which is called a pipe, followed by a bigger sign that basically says what happens here, hand it over to what you write in the next line, and we can just call this with the load function, and that should work. Oops, load without parentheses, I think. This works too. Okay, so that's the equivalent way of writing these sort of nested expressions is to just hand them over. So sometimes when you chain together lots of commands, this is a more useful thing to do. Okay, so hopefully that's given you a first quick look at how to interact and do some fun stuff with just images and so on. So let me go back and talk you through some specific ideas that you could explore. So I've made quite a few of them, so I don't expect you to be able to solve them in one day, but they sort of maybe provide a good structure for sort of working over a few days, maybe even a couple of weeks, depending on how you're going. So the first thing is to think about how to set up this Julia notebook stuff and get a little bit more familiar with it, right? So this might actually take you a little bit of time. There's some videos that you can watch to help you get off the ground. I really recommend these computational thinking lectures, which are really well done and nicely curated. You can get some help on setting up the notebooks. It's useful to have a nice text editor if you're sort of typing lots of text. So I use Visual Studio Code, which is quite nice. And that might allow you to make some notes rather than typing straight into an email program and so on. And I will show you in a minute where we can exchange ideas on a sort of online forum that I have set up, where you can get some feedback from me. So the specific ideas and problem sets that I've thought up for you all is, so the starting point is that images are sort of tables or grids of numbers. Okay, so one very useful first exercise to get going is, if you imagine a list of numbers like these 4 numbers here, can you think of a way, maybe writing a function or even just playing around with Julia in general, of actually turning this list of numbers, which is basically just got 4 entries in a row, into a table? Okay, so in this particular case, there's 4 numbers. So I'm imagining you're going to turn them into a table that's 2 by 2. The general case is if you had 9 numbers, you'd maybe have 3 by 3. If you had 64 numbers, that would be 8 by 8, right? So anything that's square, you can turn into a square table. How would you do this in code? What is the generalization of this if you had a rectangular image? Can you think of a way of doing this? So these are not easy things to think about if you haven't thought about them first, but it's sort of a nice little nut to crack. Okay. So the final point here, can you think of a way of making this function more generic? Might sort of make your head hurt a little bit, but that's sort of intended. There's another useful manipulation which people often do, which is they turn these tables, which have a certain number of rows and columns, which get displayed as images, into one long list or vector. Can you think of a way of doing that? What's involved? Can you find out how to do it in Julia or in Python? And what are some of the issues if you're trying to do this, right? So as a hint here, you might want to think about what are rows and what are columns. And if you are turning a table into a list of numbers, do you go across or down first? And how would that affect what you're doing? And then as a slightly more generic thing, can you figure out how to, and look up how to use these Julia packages called images, mat, which allows you to load in MATLAB files, which is a sort of a common format for storing scientific data, and these nifty images, which is very good for brain images, as well as PNG and so on. Can you load in one of those data sets and start manipulating them? Okay. So I think taken together, this probably keep you busy for quite a few days. Even, you probably won't be working on this solidly, but maybe you'll do a little bit of research about how these brain images are being used on the side. Keep a diary of questions that come up, right? Because I'm probably not going to be available for the first couple of weeks of the summer holidays while you get going, because chances are I'm away on a family holiday. But I will come back at some point and I'll be able to address some of those questions, right? Things that have made you stop and think for quite a bit of time. So in addition to that, I've set up a Slack channel to which I will invite all of you, where you can exchange ideas amongst each other, right? So remember that some of the people in this group are undergraduate students, some of you are still at high school. Just be nice to each other and respectful. My general rule is there's no stupid questions. So as in, you should feel free to ask anything, even if it strikes you as really quite simple. Maybe at first, because chances are that if it's something that confuses you, then other people might well find it confusing too. I'll try and ask a couple of my PhD students to pop onto that Slack channel every now and then to maybe help with some generic answers. Keep in mind that they are probably not Julia users, but they're more interested or more used to using MATLAB and Python, so also be gentle with them. But they have quite a bit of experience dealing with scientific data, and they will have a couple of years of programming under their belt at least, in some cases even a bit more. So they might be able to answer some generic questions and guide along some of the discussions. Okay, so I hope you find this useful, and I will post another video at some point in the near future with some of the discussion points of things that were raised in this thing here. All right, enjoy, and I will see you very soon.